Hi everyone, you're watching video notes 6.5 and we're going to solve by factoring. So the first thing you need to realize is that we are solving equations. Okay, I thought I just hit my pen and it's not working. Solving by factoring. So in order to have something to solve, it has to be an equation. So we're going to solve an equation by factoring. What are the zeros of this function, x squared minus 2x minus 3? Label them on the graph. So you're looking at a graph already done for you, x squared minus 2x minus 3. And the zeros are at -1 and 3. The zeros are where y is equal to 0. So -1, 0, 3, 0. So x equals -1, x equals 3. Use substitution to verify that the positive 0, that would be this one, is correct by showing it makes y equal to 0. So we're going to start with y equals x squared minus 2x minus 3. And you're going to see what the y value is when x is 3. So you're going to square the 3 minus 2 times 3 minus 3. Calculating that would be 9 minus 6 minus 3. That's a 9, 6 minus 3. 3 minus 3. Yep, it gives me a 0. So this y value ended up being 0, which means it's exactly what we wanted. Factor the expression. So here's the same thing that we graphed, but it's an expression now. It's not an equation. It doesn't have an equals anything. So just simply factor it. So when we did factoring, we did the box method. We started to think about the x squared and the -3. This has to be x and x. This has to be x and x. We got to make this -3 happen, so it's got to be a 3 and a 1. That's the only way to make a 3. If it's going to be negative, one of them is going to be negative, and this would be a 3x and a 1x. In order for this to be a -2, I need the -3 to be negative, so this has to be -3 and +1. Otherwise, you could graph it just looking at the zeros. If the 0 is -1, the factor is x plus 1. If the 0 is 3, the factor is x minus 3. So these are the factors. And how do they compare to the zeros? Exactly what I just said here. Change the sign on the 0 to create the factor. Based on C, determine where the zeros, I think it's supposed to say what are the zeros, algebraically. So these factors, x minus 3 and x plus 1, are going to make this y value equal 0. So simply put, you're replacing the y value with a 0 in order to solve this algebraically. So we can now solve. When you solve, you should be thinking get x alone. So we're going to say that if this is a product making a 0, then one of these two things must be a 0. So we're going to say, oh, what the heck did I just hit? Hold on a second. Let me get back to where I was. X minus 3 could make a 0. Adding 3 over to the other side, x equals 3. We're using the multiplication property of 0. X plus 1 equals 0. Subtract 1 from both sides. You get this simple little linear equation. X equals -1. So you can see that you get your 3 and your -1. Verify using a table. So I'm going to take a look at a graph and a table of this. The -1 made a 0, and the 3 made a 0. So graph table and look for your zeros. All right, so these are already in factored form. So that means that one of these factors, to make this product equals 0, one of these factors must be 0. So x plus 7 equals 0, or x minus 2 equals 0. And we use that to solve these simple little equations. Take 7 away from both sides. X equals -7. Add 2 to both sides. X equals 2. So -7 and 2 are the two numbers that if you put them in here, it would make this come out to be 0. Those are your answers. Those are called solutions. And they're also called zeros. And they're also called roots, if you look at them on the graph. Okay, this one, the factors are already set equal to 0, so you're just going to say that each of them could equal 0. 3x plus 4 could equal 0. These are a little bit harder to solve, but you guys are pros at this. Add 1 to both sides for this one. You got 2x equals 1. Now divide by 2. So you had that extra step there, and you get a fraction. Don't let that bother you. X equals 1/2. 1/2 is a perfectly good number. Don't mess with it. Subtract 4. So 3x equals -4. This time we have to divide by 3. So x equals -4/3. It's okay to have a fraction. Those are the two zeros. This one, it is in factored form. It just looks a little weird because you had an x out front, which means x could be 0, and that one's actually done. X plus 9 equals 0. Subtract 9. X equals -9. So this, if you looked at this on a graph, you'd have a 0 at 0 and 1 at -9. Perfectly fine. You can have an intercept at 0. It's just a little weird looking. On the next page, these are going to be a little bit harder, I believe. So you're going to find the roots or the solutions by factoring. So since they're called roots or solutions, otherwise known as zeros, you're going to replace your y with 0. So you're solving x squared plus 4x minus 12 equals 0. So factoring. Now we have to do the factoring. That's why it's got a little harder. So if you wanted to, you could graph them, and you could actually find the zeros on the graph and then create your factors. So this is x and x. And if you looked at a graph, you would see the zeros and change their signs. Let's see. I know they're at 6 and 2. I know that this would have to be a plus and this would be minus. So they must have been at -6 and +2 must have been the zeros if you looked on the graph. So then x minus 2 equals 0. Add 2. X equals 2. That's what we saw on the graph. X plus 6 equals 0. Subtract 6. X equals -6. If you look at B, it doesn't have the 3 pieces that we've been doing our factoring, even in the last couple of days when we've been completing the square. So this is like a 0 here. Or you could just say, wait a minute, these two things both have an x, and remember way back to the GCF process. So there's my 0 again. I'm going to replace y with 0. And I'm just going to factor by using a GCF, take an x out of each of these pieces. That's x minus 14. Set each of those pieces equal to 0. So I'm going to put the equals 0 over here. It just looks more normal to me. So x equals 0 or x minus 14 equals 0. All right, this one's done. X is alone. This one you need to add 14 to get x alone. So this is going to be 14. Again, if you were to graph this, you would see a 0 at 0 and a 0 at 14. And you could totally confirm your results graphically. When it says algebraically, however, you have to show these steps that I'm showing, the factoring and the setting it equal to 0 to get x alone. All right, let's look at this one. We haven't seen one of these in a while. If you remember the whole difference, I called these dots in my class, difference of two squares. To factor this, x squared minus 25 equals 0. We're replacing our function with 0. This is a perfect square minus a perfect square. So this was x and x, 5 and 5, plus and minus. It's not a perfect square trinomial. It's a difference of perfect squares. The middle term, which I called OI in my classes, the outers and the inners, give me that 0x in the middle. That's why I need two different signs. Anyways, I got my factors, and I'm going to set them equal to 0. So I have x plus 5 equals 0. Subtract 5. I get a -5. X minus 5 equals 0. Add 5. I get a 5. So those are my two zeros. And you could confirm that on a graph. This one, I looked for a GCF for factoring, And there isn't one. There's nothing in common. Nothing. It doesn't even look like an X. Okay. There's nothing in common. So I would probably go to a graph. I'm going to take a minute and do that. And I'm going to look for where the zeros are and then work myself backwards into my two factors. And I'm going to replace my y value with 0. Okay, so I looked at a graph. Here's a picture of it. And I traced it to find the 0. And the 0 was at -4, 0. So if my 0 is at -4, that's my nice one. My other one was a fraction. So we'll talk about that one in a minute. But that gives me x plus 4. Then I look at this 2x squared, so I know I need a 2x. And this is a -12, so I know I need a -3, because that would be my -12. So I know that those are my factors. I could confirm with the box method, whatever you need to do, but those are my factors. Setting them equal to 0, x plus 4 equals 0. Subtract 4, x equals -4. 2x minus 3 equals 0. Add 3. This one's got 2 steps. So I still have 2x. X is not alone. Divide by 2. And x equals 3/2. So this fractional root must have been a 3/2. Those are my two zeros. And again, confirm them on your graph, but do the algebra. All right, I'm going to take a minute and graph 6x squared plus 23x plus 20. So this one's a little bit awkward. Both of the zeros are fractional numbers or decimals, -2.5. And the other one is, I'm using trace, but my calculator's not cooperating. The other one was at -1.333. So -2.5, x equals -2.5 is -2 1/2, or -4 plus 1, or 4 plus 1, 5/2, -5/2. I'm going to use that to help me create my factor. That would be a 2x, change the sign, plus 5. Now I know that's got to be a 3x to make my 6, and that's got to be a plus 4 to make my 20. So I got my factors, equals 0. Remember, that's just to help me over there. Set these factors equal to 0. 2x plus 5 equals 0. Subtract 5. 2x equals -5. Divide by 2. And you got -5/2. It really does help if you could change a decimal into a mixed fraction. The other one, why is that not working? 3x plus 4 equals 0. Subtract your 4. Divide by 3. If you remember from looking at my calculator that wasn't cooperating, it was -1.3 repeating. That's the other way to write -4/3. All right, so I'm going to take a minute and graph x squared minus 5x plus 8 on my calculator and see what I get for factors. So look at this graph. This is a little bit strange. The graph is floating, so it has no zeros. So I'm going to go back to my paper here and note that when I tried to get a graph of this, the graph was floating. There are no zeros, which means I could try all day to factor this thing and set it equal to 0, x and x. I'm looking for numbers that make an 8. So what? 8 and 1, 4 and 2. Those are never going to give me a 5. This is not factorable. If it's not factorable, I can't set them equal to 0. I can't find zeros. There are no zeros. That happens. That's why using a graphing calculator really helps.